train leaves the station at 1 o'clock p.m. traveling due west. Another train is coming south at the same time, and we want to know when the two trains are closest together. Well, this is a relatively lengthy solution, so I'll give you a screenshot of it to start if you want that. Okay, and now we'll go through it step by step. What we can do at the start is recognize that the first train traveling straight west from the station, we're going to think of the station as the origin, west is to the left, so we can say that at any given time t, the position will be negative 80t, 0. The second train gets to the station traveling 70 kilometers an hour after 2 hours, so it must have been 140 kilometers away. Since it's traveling south, it must have been positive 140 to start. And so the y-coordinate of that second train is going to be 140 minus 70t at any given time t. Now, what we can do is figure out the distance at any given time t between them, and that's a simple matter of x1 plus x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Okay, and expanding that out and collecting like terms, we get that at any given time t, the distance in between them is the square root of this quadratic expression. Now, at this point, we want to take that derivative and set it equal to 0. And that will give us the correct answer. But we can also see that the time making this quantity here the greatest will also be the time that makes the interior of it the greatest. And so what we're going to do is avoid the chain rule by simply dealing with the interior. Since d at t is the square root of that quadratic quantity, I'm going to let capital D of t be just the interior of that quantity, as indicated right here. Now, taking the derivative and setting it equal to 0, I get a t value of approximately 0.867. Now, my domain is all t values between 0 and 2. And you might wonder how I know to cut it off at 2, but we know that because when t is greater than 2, the second train will be heading south and will be heading farther away from the origin, and the first train will be also heading west farther away from the origin, so they'll both be traveling farther and farther away, so there's no way that the movement of one will counteract the other and make their distance shorter. So we can logically cut off our domain on the upper end at a t value of 2. So plugging in a t value of 0, we get a distance of 140. We knew that because the first train was at the station and the second one was 140 kilometers away. And at 2, we know the second train's at the station and the first one's 160 kilometers away. But at a time of 0.867, they were only 105.4 kilometers apart. That's the closest that they were. Now, to put this into time for the average citizen, what we want to do is figure out how many minutes 0.867 hours represents. So all we do is take that quantity and express it as a fraction over 60. The numerator is 52. So since this started at 1 o'clock and 52 minutes later they're the closest they ever get, we can say that the trains are closest at 1:52.